Hello, so this is our demo regarding the course EEC 455 project. And our project was project number 12, which we had to implement the RSA algorithm. And we had to implement it using two key sizes, 1024 and 2048. Our team members include myself, Sabra Annan, Hassan Sabra, Osman, and Kamar Fadlallah. And we all worked together to generate this solution. And this is the corresponding simulation that we came up with, and I'll walk you through it right now. So let's say we chose the key size of 1024. We want to write the message that we want to run the simulation on it. The simulation basically takes the message, encrypts it, and then decrypts that same encrypted message, and we see how we get back the same message successfully. So let's begin. Let's say we want to encrypt the message, hello world. We run the simulation, and these are results. Basically, we have the results and the steps that we use to generate the keys. So let's start with the results. Our message string was hello world. Its corresponding bytes are the following. And basically, we want to work with numbers when we are doing the RSA algorithm. So we basically converted the message string into bytes, and then we encrypted these bytes, and then we correspondingly decrypted the bytes that we got as answers to get back our string. So here, after we converted it to bytes, we try to show you the encrypted string and the corresponding bytes. And then these are fed into the decryption function, and we get back the bytes, which as you can see are the same as the initial bytes. And successfully, we get back the decrypted string, which is hello world, like the one inputted here and here. And these are like the general view of the results. Now to dig deeper into the steps of how we got these keys. So as you can see, the key size selected was 1024, like we selected in the radio buttons. The first step was to select the primes. These primes were generated randomly. This is P and this is Q. They're both prime numbers. Step number 2 was to compute N, which is P times Q. And this was the corresponding answer after multiplying the above two numbers. The third step was to compute phi of N, which is P minus 1 into Q minus 1. And we got the corresponding answer. The fourth step was to select E. And to select E, we wanted it to conform to this condition where GCD of E and phi, the one we got above, is equal to 1. So we chose E to be the following. And then we want to determine D. D was simply determined using E, and we wanted them to be inverses, and we wanted D to be less than N. And this is the D we came up with. And then for the sixth step, we officially publish our public key, PU, and it was the corresponding pair. This is N that we got previously, obviously. And then for our private key, we also got the following results. Of course, this key is supposed to be kept private, but we demonstrated it only for the demo purposes to see that the code is working. And these are the steps that we followed. And now say we want to choose a key size of 2048 and encrypt the same message, let's say. We run. And of course, we get back correctly the same message. And as you can see, it's much longer since we chose a different key size. And here the steps are the same with corresponding longer numbers, as you can see. And of course, whatever other message we write, cryptography, let's say, run. The algorithm is running successfully. Our initial message was cryptography. Our return message was cryptography. And also whatever the size, hello. As you can see, it's also successful. That's basically our demo, and thank you so much, and hope it was beneficial. Bye, thank you.